Good morning, everybody. Thanks for joining the partnered CEC and scale computing webinar today. As some of you know, last week we kind of set up this webinar. Steve Foley and I did to introduce you all to hyperconvergence and how it can help in business resilience. And today we hope a gentleman named Jared Pexa is joining us from Scale Computing, and we hope he kind of puts the nail in the coffin here as far as connecting the dots for everybody. So my name is Jim Anderson. I'm the general manager of IT here at CEC, kind of play the CIO role for CEC. In case some of you don't know, here's a little introduction slide to CEC. Specialize in 5 main technologies: audio, video, IT, structured cabling, safety and security, two-way communications. We support 7 markets and our 8 office locations. We have Des Moines, Dubuque, Davenport, Waterloo, Cedar Rapids, which is our corporate headquarters. And in Wisconsin, we have offices in Milwaukee, Madison, and Green Bay. So we're excited today to present Scale Computing to you all as a hyperconverged solution because it fits all of our the verticals we focus on, and it fits all of the markets that we support. So I'm going to mute myself and turn off my camera and release you all to Jared Pexa.
I appreciate that, Jim. So yeah, just first and foremost, want to thank CEC for letting us come. Appreciate that, Jim and Steve. So my name is Jared Pexa. Work for Scale Computing. I'm the North Central Systems Engineer. Just to kind of quickly level set on an agenda. So obviously, I want to talk to you about what the topic of the conversation is today. So we'll kind of set the stage with a little discussion about business resilience, what that means to us, and how we think as a company, we can help companies and users address that. And then from there, I have roughly 20 slides, but I promise I won't spend too much time on the slides. I will get to what I consider the fun part, which is actually getting to a demonstration of our UI and our product and what it would kind of look like on a day-to-day management, or from a day-to-day management perspective of managing scale. One of the things that I do want to say right on the forefront here is that I do have 2 dogs at home, and I actually have someone to come and clean my gutters today. So there could be a brief disruption of my dogs going crazy if someone pulls up to the house. So just want to forewarn everyone that I might need to take a brief pause to settle them down. With that being said, let's get started. So I like this quote here from Gartner, just kind of looking at, 2020 and moving into 2021, or the second half of 2020 and moving into 2021, that CIOs have moved into an emergency cost optimization, which means investments will be minimized and prioritized on operations that keep the business running. And that will be the top priority for most organizations running through 2020 and moving into 2021. The reason for that, right? Obviously, it's been a crazy year in 2020. We all know it. I don't even like to bring up COVID. We've all been probably COVIDed out, but it is real. It is what we're dealing with from our personal lives, and then obviously our work lives as well. So, what does business resilience mean? Again, it's a combination of proactive and reactive planning for an organization to mitigate and adapt quickly and effectively for threats and disruptions affecting the operation and success of the organization. Now, what does that mean from an IT department perspective? Well, that's what we're going to talk about throughout this presentation. So, you traditionally will think about what it means from a business resilience perspective. A lot of things you think about are DR, right? And that's obviously still part of it, but we'll talk about some of the other components throughout this presentation. So how have organizations responded to COVID and kind of going post-COVID? Hopefully we get the vaccine and kind of can get back to normal life here soon, but I think there's kind of a new norm anyways, post-COVID. So, the initial reaction, if we look at this from a 1, 2, 3 perspective, the initial reaction was obviously to go purchase a bunch of hardware, laptops, et cetera, to enable that remote workforce. we're going to talk about kind of is 2 and 3. How do we, move forward past that? So number 2, obviously looking at potentially a complete VDI implementation. A lot of companies that I've spoken to are looking at, kind of having remote workforce, or at least an enabled workforce to work from home or work from anywhere is going to be kind of part of their ongoing strategy moving forward. So obviously we'll talk to you about how we can help address that. Security is going to be at the forefront of, as always. I think with COVID and the additional exposure of workers working from home and extending corporate VPNs could potentially have opened up a little bit more risk for a lot of the companies that we work with. To talk about that, and then obviously moving into number 3, just operational innovation, how we can kind of look moving forward. So business resilience, again, just kind of recap. The one that kind of comes to the forefront, at least when somebody says business resiliency or business resilience to me, is having, HA and DR from an infrastructure perspective. But beyond that, like I mentioned, working from anywhere, enhancing your security, backup, obviously a big one, and then scalability as well. So a few misconceptions about business resilience, that you already have a DR plan in place. It's very often that, I'll talk to a potential customer and we're talking through their DR plan. And, a lot of times it might be something like, yeah, I have backups and I have backups off site. But in reality, if, we had something happen to the infrastructure, that was actually devastating. That there would not be really a plan. The plan would be that I need to rebuild from backups, and that could equate to quite a bit of downtime, especially for customers that I talk to that maybe don't have a highly available solution. Maybe they just have a single host, and then they're backing up that host and backing that up to maybe a cloud target, which is all good. But, you have to kind of think about that future thinking, what would actually happen if I had, some sort of disaster, whether that's an actual disaster, flood, or, fire, or, maybe it's just fiber line gets cut, and, do we have anywhere else that we can run our workloads? And, so there's all of those considerations that you have to come in mind, or take into consideration, I should say. I don't have time for business resilience. Well, I think, we can all say that that's, probably not very forward thinking. And I think most people would now accept that it is important to look into the future. And then the last one is my employees can work remotely on laptops via VPN. Although that is a solution, and, we have plenty of customers doing that. Again, want to reiterate that, we've seen a mass, explosion of the amount of ransomware attacks, ever since COVID has come about. Correlate that to the likelihood of that being that we've seen that increase is that, those corporate networks are being extended to what we'd consider probably the most unsecure networks, which are home networks. So, candidly, that just makes it easier for attackers to get through to the corporate network that way. So we'll talk to you about, kind of keeping everything in that highly secure corporate network and, just kind of broadcasting out via VDI. So a few technologies for business resilience. Obviously, HCI, that's, what we'll talk about. That's who we are as a company. That's what scale computing is. I'll talk to you about what HCI is, or hyperconverged infrastructure. VDI, I've mentioned this a few times. We'll talk about that in more detail. Ransomware protection, and then backup and DR. So setting the stage, Scale Computing is a company. If you have not heard of us, we'll just take this, few minutes here to give you a brief kind of history and introduction of for Scale as a company. So we were founded in 2008, launched for 4 years or so. We had a scale out storage product, but the end game was always the product that we currently support, which is HC3. That was launched in 2012. We have, currently it's over 3,000, I want to say around 3,500 customers, over 10,000 nodes deployed globally. So even though you may have not heard of us, I like to say we're the best kept secret in the industry. We don't spend tons of money on marketing. We're highly reliant on referral business, whether that's, our existing customer base, spreading the good word about us, or obviously great partners like CEC that have, spent, and for those of you that have been on the previous sessions, obviously, that CEC themselves is a believer in the fact that they have implemented Scale for their corporate infrastructure, their internal infrastructure, and have implemented the DR components as well that we will be talking about. Technology partnership, you can see a whole host of different technology partners there. We'll focus on a couple of these throughout the presentation here and hit on those. If you have any interest, if you're the type of person that likes to read reviews, you can see that Trust Radius, Gartner Peer Insights, Spiceworks, Tech Validate, feel free to go search any of those about us and you'll see real reviews, and potentially from, likely you can find some from people that are in the same industry as you. And then of course you can see the multiple awards that we've gotten there. So what is HCI? So there might be some people on the line that are still like, I've heard of HCI, I've heard of hyperconverged. Is that just a buzzword? What is it? So we'll take a step back. Well, what is HCI? Essentially, the best way for me to describe it from a high level is you're kind of going back in time in the sense that you're bringing storage back internal to the hosts themselves. In the HCI world, we call those nodes. But you bring that storage back internal, and really the special sauce is the software layer that is able to converge the storage from individual nodes to a single pool of storage. That's really what it boils down to, because then at that point you have highly available storage across multiple hosts or multiple nodes without having to have that backend SAN, which could potentially be a single point of failure. On top of that, there's a lot of our competitors in the industry that are also out there, HCI. I mean, if you go explore the market, you won't just find Scale Computing. There's other competitors in the market, of course. But where we differentiate is a couple things. We'll talk about it. But one of the differentiators is the fact that we also provide the hypervisor layer. So we integrate our hypervisor to work seamlessly with our storage layer. That's a big selling point. I mean, for customers that have historically had to pay the VTax or, have been running VMware for years, and you see the massive renewal that you have every year, well, potentially eliminating that from a cost perspective is big. And what we've seen industry-wide as a trend is that VMware's losing market share. I mean, quite frankly, there's a lot of alternatives now, and those alternatives, including ours, are KVM-based alternatives. And a lot of customers are realizing that, they can go to an alternative that's included in the product like ours and not have to pay that additional licensing cost. So if we look at it from a traditional architecture to our architecture, so on the left-hand side, this would be representative of, probably a small to medium business, mid-market customer that has 3 hosts. But regardless if you had 3, 4, 5 hosts, it doesn't matter. Same type of model here, right? From a graphic perspective, you have 3 hosts, you have 2. It's the 3-2-1 architecture, right? 3 hosts, 2 switches, and a SAN, right? Where this, this has been implemented for years, right? And it's a solution that works, but when we start to compare it versus our solution, some of the differentiators that we see is that traditional way of doing things can create a lot of unneeded complexity really throughout the entire ownership of the product, unneeded complexity from the initial implementation, the ongoing management, and then if you ever need to upgrade the solution, it can be very complex. Why do I say that? Well, because you're dealing with multiple vendors. I mean, at the very minimum, you likely have 3 vendors in that stack, potentially more, but you have some host vendor, right? Whether that's Dell, HP, Cisco, whoever. You of course have the hypervisor layer, which is likely VMware, maybe Hyper-V. You have the SAN, maybe it's a traditional EMC SAN, NetApp, Agile, there's a million of them out there. But when you have all these different components, different vendors, that creates complexity inherently because you need to look at all of these different compatibility lists. And then if you actually have any issues, potentially you open a support ticket with one of these vendors and they say, oh, no, our stuff is operating fine. That sounds like it's a VMware issue, or vice versa. VMware says everything looks good on our end. That sounds like it's an issue with your SAN. And potentially you're having to play the quarterback role of saying, okay, well, everyone's saying it's not their fault, so I have to figure this out. And, potentially making other vendors talk to each other. It can be very complex and very time consuming. and just not ideal. And like I mentioned, also the expansion piece. I mean, potentially adding an additional host to a traditional host and SAN deployment like that can be quite complex. Again, just looking at hardware compatibility list, understanding if this is going to degrade performance. Do I get any benefit of adding newer, more powerful hardware, or is it all going to default back to the lowest common denominator? A lot of things that go into that just make it very challenging to manage that infrastructure. Now, virtualization the HC3 way, very, very easy. I mean, from an implementation standpoint and ongoing management, the ongoing management I'll show you in the demo, and you can see it live. So, I mean, hopefully once you've seen that, you will believe what I'm saying here. But even from the initial implementation perspective, I've implemented scale clusters across the Midwest in this role, and literally have never dealt with an easier technology to implement. It's as easy as getting it out of the box into the rack and cabled up. From there, it's literally assigning IP addresses to each one of the nodes and doing one command that says initialize cluster. From there, you're looking at the scale UI that I'm going to show you here shortly, ready to start migrating existing workloads over from your existing VMware or Hyper-V environment or Zen or whatever you have, or even physical environment over to HC3, or building net new workloads, uploading ISOs. One of the other big comparison points from us versus some of the other HCI players in the industry is there's really two ways to go to market from a technology perspective. The left-hand side, which is called the virtual storage appliance, virtual SAN appliance, you've probably heard of it a couple different ways there. But what the net of that is it's essentially running an emulated SAN technology within a VM on each one of those nodes. Now, our competitors will call that particular VM that's running on each one of those nodes something else, controller VM, Omni, Stack, virtual controller, something along those lines. Usually has controller in the name of it. And again, not here to bash competition. That technology works, but there's really 2 points where it kind of is less efficient, obviously, from an IO path perspective. If you look at that green or the red line on the left-hand side, that's how many hops it would take to do something as trivial as changing a period to a comma and hitting save, because it needs to communicate, obviously, not only with the hypervisor, but the VSA on each one of the nodes. Whereas on the right-hand side, with what we call the integrated hypervisor model, you may have heard this as kind of the in-kernel approach, we're literally 3 hops. It's down from application to RAM, committed to disk, across the backplane network, committed to another disk redundantly. So that's one point. The other point is the resource overhead consumed in the VSA model. We're talking about a minimum of 32 gigs of RAM and 4 cores per node consumed just to turn the infrastructure on. You extrapolate that across the 3-node cluster, talking at a minimum 96 gigs of RAM and 12 cores consumed. Likely it's going to be more than that. I've done some replacements for some of our competitors. I won't name names, where that virtual controller has had upwards of 100 gigs of RAM allocated to each one of those virtual controllers. We go ahead and replace that. We're able to come in with a much more cost-effective solution, because obviously we're not building in all of the resources required just to turn that technology stack on. For us, same model, where I just said anywhere from 96 to 300 gigs of RAM, we reserve 4 gigs of RAM per node. So it's roughly 12 gigs of RAM across the 4-node cluster and a fraction of a core. So just much more efficient from a technology perspective. That also really, really helps not only in your core data center, but for customers that have multiple locations that require local infrastructure. Obviously, that's just that multiplier that you have to deal with, whether it's 5 sites, 10 sites, whatever. That low resource overhead really starts to become very important when you're talking about multiple sites. So a quick overview. Again, I hit on a lot of this, so I won't spend too much time here. Simplicity, like I said, deploys very, very quickly, less than an hour. That's the truth. Like I said, I've done these myself. Scalability, this is a big one. So we do have the ability to support single node configurations. So if there's a use case where you don't necessarily need high availability at a site, we can do one node out there, but it's still going to be managed under the same umbrella from an HC3 perspective. So you could replicate that single node back to a DR cluster or back to the production cluster to protect that data, just using built-in Scale replication. Scaling out, that's another big one. When you add a node, when you need to add resources, for one, you can mix and match, so it doesn't need to be exactly the same node. So for example, I've had customers that just want to add, maybe they start with a 3-node hybrid cluster and they want to add just additional capacity, but they want to minimize cost on what they're adding. They don't need additional performance. Well, we could potentially add just an all spinning disk node to that cluster. Where the original 3 or 4 nodes maybe have tiered nodes that have SSD and spinning disk, but performance is great on the cluster. They just need additional kind of slower capacity, maybe for snapshots or just kind of archival data. We could just add simply another spinning disk node. On the flip side, maybe we just add an all flash node. So very, very flexible from that perspective. And when you do add a node, it's about a 10-minute process for the resources to be sucked up and included in the cluster, and obviously seeing that 4th or 5th or 6th node included into the cluster. Affordability, this is a big one. That's obviously one of the main reasons we've had a lot of successes as a company. We're eliminating the need for that third-party licensing, just the VMware licensing. On top of that, obviously we can eliminate a lot of other licensing as well. I mean, since we have built-in data protection suite within the product, potentially eliminating things like Zerto or other replication technologies that are being utilized. And then also we don't play the game of having, multiple licensing levels. So we're a company that's very forthright, whether you're buying a cluster that's 30 grand or buying one that's $1 million, they have the same software features built into the product. So there's not a starter, pro, and ultimate edition. It's just, it is what it is. You get all of the features regardless. So from a workload perspective, I mean, as you can imagine, you name the workload, we probably have a scale customer running it on an HC3 cluster. Just a quick overview of the entire kind of lay of the land from a scale perspective, from a product offering. So everything from the very smallest on the left-hand side to your core data center on the right. I'll highlight a couple of these. Not going to talk about every single product. But on the very left-hand side, you'll see the HE150. This is a pretty unique product offering. This is actually based off of Intel NUCs. So really the target here is for any type of smaller remote sites or, just sites, and they don't necessarily have to be small sites, just sites that have fairly small or, maybe 1 to 10 max virtual machines that are running out at those remote sites, but still require HA or still would like to have HA. Maybe traditionally you put a single host out there with maybe a backup host or something along those lines. But, it's never been realistic from an affordability perspective to be able to have HA at those sites. Well, now we've made it a possibility by having these small devices that are cost effective, that, have the full software suite built into them. Our whole, still has the hypervisor, our storage layer, and everything's still highly available, but built on something as small as Intel NUCs. On the flip side, on the core side, of course, we have very, very dense nodes. For the high performance needs, we have all NVMe based nodes, so we can really run the gamut from the smallest of small to the largest of large. So kind of getting back to the topic of the conversation, right? Business resilience. So I've talked about some of this, just built into our product. Obviously built-in data protection capabilities, built-in replication, which we'll talk about. But here's kind of, taking it back. So built-in DR. So very common for customers to have a multitude. There's different options, right? So you can do, like for like at site 1 and site 2. You could have a 3-node cluster at site 1, a 3-node cluster at site 2, or your DR site, doing replication from site 1 to site 2. Most customers, don't necessarily have the luxury of having identical hardware at their DR site. So it's very common where I'll look at highly available 3 or 4 or 5 node, however many nodes we need at site 1, and then maybe doing a single node at the DR cluster or at the DR site that's built accordingly. You build it with, enough storage to replicate over all of the workloads, but you just build it with enough compute resources to run what's deemed actually mission critical. So one of the exercises I always do with customers on the pre-sale side of things is looking at, okay, let's determine which workloads are truly mission critical. From there, we're able to size that node appropriately. Now, adding on to that, we formed a partnership quite a while ago. I want to say it's a couple of years ago now with Acronis, but as of recently, we've actually worked more in line with them to the fact that now we have a agentless offering with Acronis from a backup perspective. So fully integrated with Scale, doing things like restores are super simple, a couple clicks, whether you want to restore to a brand new VM, the existing VM. Really, I like to talk about this as Scale backup powered by Acronis. I mean, that's really the level of tight integration that we have between the two companies. So much so that we actually resell the software and actually we'll take support calls on it as well. So, there's potential that we would have to escalate that to Acronis, but we would still quarterback the support calls. We'll take anything, kind of deemed level 1 and 2, anything that our team can't uncover, then we would escalate that up through the channels, but still keep ownership of the ticket as well. One of the, one of the real cool things that Acronis brings to the table beyond backups and the integrations that we have with them is also ransomware protection. So this is a big one. I mean, unfortunately, there's a lot of bad actors out there, a lot of people, trying to hack in, and get money out of companies, right? So the ransomware protection from Acronis is called Active Protect. So if you want to look it up, it's, just Google Acronis Active Protect. You'll find more data on it. But from a high level, what it's doing, it's using machine learning, AI-driven technology to say, okay, I'm monitoring this machine and I'm going to monitor anything that I'm protecting for any type of irregular changes, really. I mean, if there's any type of, the best example that I like to use is, if all of a sudden the machine starts to become encrypted, right? And the machine's files and folders have, historically never been encrypted, and this is automatically kicking off, well, that's going to be considered irregular behavior. So what Active Protect from Acronis can do is it actually can stop that process and revert the files from when that happened, so that's restored back to its original condition, and then of course send a notification to the admin. So that's been a really powerful tool in terms of the relationship we have with Acronis. And again, and this is why, right? So the ransomware, I kind of mentioned this before. This is kind of a dated slide, but from just the very beginning of COVID, there's a significant increase in ransomware attacks. And again, here's the little quote from cybersecurity strategists. It's easier, frankly, to hack a remote user than it is someone sitting inside of their corporate environment. Again, that goes back to extending the corporate network out to the end users at home. So the legacy way of doing things, it's maybe a little harsh here to say exactly the wrong thing to do, because I know there are a lot of people doing this, but we'll talk about why and how we could potentially do it better. So deploying those company laptops and tablets out to the end users, one that's of course increasing security risks, but then extending that VPN out to remote users to obviously the less secure home networks. You spend so much time and money and effort on securing your corporate network, you don't want to necessarily extend that corporate network outside of the walls of your data center. And we can talk about how you can do that via VDI. So VDI with Scale, a few things here to point out. We've chose to partner with two companies. We've chose to partner with LeoStream and Parallels from a VDI perspective. Both have their benefits. If there's any interest in speaking more about this after the conversation, specifically when it comes to VDI, feel free to reach out to myself or Steve or Jim, and we can, obviously do a whole nother conversation tailored just to this. But the reason we chose those two partners, really two reasons. One, more affordable than your traditional VDI deployments like Citrix and VMware Horizon, but also just a lot easier. I mean, I've actually went through the exercise of setting up both of these with my internal team for our demo clusters, and it's just the deployment of the software is so much easier to get a VDI set up and running. And obviously we have experts like myself that can appropriately size the actual underlying infrastructure that you'd run the virtual desktops on. So a couple things, what are the components of a VDI setup, in case you're wondering? Of course, we're bringing the desktops back to the data center. We're running them on servers, and really, how do users connect to it? Well, depending on where they're connecting from, if they're connecting within the office, then they can target just the connection broker itself. If they're connecting from outside of the network, well, then again, we're just using a display protocol. So your corporate information, your machines are running within your corporate data center. And really what they're accessing is just the display protocol via a gateway through the internet. So it makes it much, much more secure than extending that VPN network to your corporate or to your home users. A couple things here, of course, here's some just random stuff from an award perspective. Again, I feel free to go to any of these sites and read the reviews yourselves. Here's a few different customers that we have, some more common names, and then here's some mid-market customers as well. So with that, I want to jump into what I think is probably the most entertaining part. I'll probably go a little bit faster than I normally do on these demos just to make sure that we reserve enough time at the end, but let's get started. So this is the Scale user interface. How do you access the cluster? First and foremost, we simply need a web browser. Point that browser to any one of the IP addresses of the nodes in the cluster. I happen to be pointed to the first node in the cluster, but I could point to .11, .12. It doesn't matter. We take what we call a distributed management model, meaning there is no master node in the cluster, no one node that's the brains of the operation. Obviously, that would defeat the purpose because we've designed the product to be highly available to lose any components, including an entire node, without very minimal disruption. While I'm talking about it, might as well go through that scenario. So if we lose an entire node, what happens is that automatically will kick off a live migration process, or I should say an HA event, and would automatically restart any machines from the node that was lost on the remaining nodes in the cluster. Top center is all of the resource utilization dials. So this is CPU, RAM, disk, I/O, latency, everything you'd expect to see here. If you want to dive into disk utilization a little bit deeper, you simply click on the dial. They'll give you a breakdown of utilization, of course, what you have free versus VM data usage versus Snapshot usage. Jump over to efficiency. It's going to give you what you're saving with deduplication on the cluster. Last but not least, provisioned. It's going to show you hypothetically if your thin provisioned disk filled up, where you would net out to you from a storage perspective. But of course, we'd send automatic notifications as you hit certain thresholds of disk utilization. Some of them are more informational notices, just saying, hey, just FYI, you've hit 60% utilization. Of course, as you get higher up to 80, 90% utilization, they become less of an informational notice and more of a kind of a warning saying, hey, you really need to add some storage soon. Upper right-hand corner is where any kind of alerts, notices, warnings would flow through. Of course, we don't expect customers to be sitting in the Scale UI at all times, and, looking for any type of alerts or warnings. So during initial configuration, you would set that up to have automatic email alerts sent out to one or multiple people, or maybe if CEC is helping out managing the cluster as well for you, maybe they would be in there going right to their help desk as well. One of the other things I guess I forgot to mention is just from an architectural standpoint, you're probably used to, if you're in a VMware environment, having to stand up a management server, aka vCenter server. Well, that's not needed in our infrastructure as well. We don't have a management server running anywhere on the cluster or outside of the cluster, because again, it's not needed. That's why we're targeting the node IP addresses directly, because the management features are built right into the nodes themselves. So the two views that we have here, if it's not obvious already, these black, gray, and white boxes are representative of the individual nodes in the cluster. Again, I use the term, or in the HCI industry, we use the term nodes. Really, it's just hosts, but in HCI world, we call them nodes. Two views we have here. First one's RAM view. Gray space is the available RAM. The white boxes are the individual virtual machines running on the particular nodes. If you do hover over those white boxes, it'll give you the name of the VM. Not very practical if you're dealing with tens or hundreds of VMs. A much easier way, if you're trying to find out where a particular VM is living, is to come down to these bigger white boxes or gray boxes. White means they're powered on, gray means they're powered off. But these are the individual servers running or not running on the cluster. If you want to find out where a particular VM is running, simply click on the move button and it's going to highlight it there for you. So I'll click on this a few times here. You can see it highlights where it's living currently. So it's right there on node 1. If I want to live migrate that to node 2 or 3, I simply point and click. It's literally as easy as that. Point to node 3, click. It's kicking off that live migration process, moving that virtual machine from node 1 to node 3 live on the fly with no disruption to the workload. Second view is the disk view. Again, pretty straightforward. Physical drive disk slot, what's in them, and how much capacity is being utilized. A few things to note about storage. We have a multitude of different configuration types. Of course, we have, all spinning disk configurations that are generally reserved for more kind of very light workloads or for kind of more of that backup and limited DR functionality. We have hybrid clusters, which you're seeing here. That tends to be one of the most popular configurations, just because we're able to get a whole lot of performance without, kind of breaking the bank going all flash. But we do have all flash configurations as well. And then, of course, last but not least, on the very high end, we have all NVMe-based SSD nodes. Coming back to the hybrid nodes, we do something pretty unique from a technology standpoint. We have a technology called HEAT. It stands for Hypercore Enhanced Automated Tiering. And it's doing exactly what it sounds like it would be doing. It's automatically tiering data blocks between the 2 tiers of storage. And it's really dependent on how frequently accessed the data is. So the net of it is your hot data will be on the SSD tier and your cool data on the spinning disk tier. However, as an admin, you do have some granularity and control on how you kind of prioritize certain workloads access to that SSD tier. So keep that in mind. I'll show you what I'm talking about here in a couple minutes when I build a brand new VM. Now, quite frankly, a lot of customers will simply collapse this because, again, the whole idea behind Scale as a company is to radically simplify management from, your seat, the people listening to this, because it just takes a lot of the thought out of it. You don't have to necessarily worry about the underlying infrastructure anymore. And that's why I say a lot of people just minimize this is because all my dials are green, my cluster's healthy. I don't really need to worry about the underlying infrastructure. I need to worry about what actually matters, which are the individual workloads moving the business forward. So, of course, we could, the short way of creating a VM is if you spent the time after implementing Scale to create some template machines, which a lot of customers do. So we have a 2016, a 2019, a Windows 10 machine here, that have all the Windows updates run and sysprep run, and they're ready to be cloned off. So if we wanted to do that, of course, we could click the clone button here, rename it, redescribe it, retag it, whatever we want to do, and simply click clone. Within a few seconds, we're going to have a virtual machine now that we can install whatever roles it's going to serve, whatever applications need to be installed and et cetera to that particular machine and go from there. But that's kind of, the short way of creating a VM, and there it is. So I'm going to delete that, clean up after myself, and we'll show you the, quote unquote, long way of creating a VM. So I'm going to come back up to, if you're wondering what these big blue boxes are, these are what we call groups. They're just logical groupings of virtual machines. So I'm going to come up to my group here under Jared so that we can see when I create my VM. We're going to call this CEC demo, and then we'll give it a description. Let's say hypothetically this is a SQL workload, and then we're going to give it a tag. So I just kind of talked about these. The first tag that you give is going to be where it logically groups it in the UI. And you can give additional tags after that. So if I tag it as, let's say, SQL, that still serves a purpose. You can see that it's not going to group that anywhere logically in the UI. However, it does still serve a purpose because I could go ahead and filter down by virtual machines tagged as SQL up here in the upper right-hand corner, and it's only going to display those machines. And then at that point, I can take a group action, power options, power on, power off, obviously, and then data protection options like taking a snapshot, a clone, et cetera. Very basic choice here. If it's a Windows-based OS, leave it on Windows. If it's any Linux variant, go ahead and select other. Then typical virtual resource allocation here. So let's say we want to give it 4 virtual CPU, 12 gigs of RAM, maybe an 80 gig system drive, maybe a 300 gig drive for logs, and let's say hypothetically a terabyte data drive since this is hypothetically a SQL workload. Again, I already mentioned this, but just to reiterate, all disk is thin provision. So, we're not going to actually all of a sudden consume, over a terabyte of capacity here. Data isn't actually, or capacity isn't actually consumed until data is written. And we come down here and select what we want to boot from. So we can see we have a whole bunch of different ISOs in here, but say we want to boot from server 2019, go ahead and click create. Now we should see this flow under my Jared tag, and there it is being created. Quickly show you where that software came from. So come over to Control Center, down to Media. You can see right here is all the list of different ISOs. It'll give you the number of mount points. You can simply drag and drop your ISOs right here, or upload them via a path, and then they'll be available in that drop down for future VM creation. Now, if we needed to make any additional changes to this machine, we could before powering it on, but let's just say it's ready to be powered on. We're going to go ahead and hit the power button. And while that does that, I'm actually going to jump back up here, because one of the cool things is I'm going to guess it's going to start up here on node 1, because what's going on behind the scenes is we're utilizing state machine technology. And that's really how we were able to develop a self-healing, self-remediating cluster, making decisions when to fail over virtual machines, when to fail over to redundant NICs, et cetera. But we're also monitoring node by node resource utilization. So we're going to intelligently place the virtual machine on the node we feel is the best place to start that machine on initially. So that's why I would have guessed it was going to start up here on node 1, because the biggest driver behind initial VM placement is going to be available compute resources. So coming back down to individual VM level management, of course, we have our power options up here. The default view here is the speedometer. This gives us an idea of what's going on in the virtual machine at that point in time. In between the power options and this default view is our console button. So if you go ahead and click on that, that'll prompt open a new window. Very usable console. I use that quite extensively when I'm doing any kind of work in guest there. Come down to devices. This will have, obviously what we've allocated from a resource perspective, what we're booting from. Here's our scale in guest tools, ISO here, automatically included. And then we come down to the virtual drives that we've created. So we have that 80 gig, 300 gig, and 1 terabyte drive. So I mentioned this when we're dealing with a cluster that has 2 tiers of storage, that we get the ability to utilize that heat technology. So if I go ahead and click more next to any of the virtual drives that we have created, it's going to expand to open up this new window. Now I have the ability to adjust the heat priority setting of this individual virtual drive. So we have all these settings going all the way from 1 to 10 that I call non-absolute settings, meaning we're not pinning it one way or the other. We're either setting a lot less priority, meaning if we turn this down, we're giving it less priority access to the SSD tier, or on the flip side, we turn it way up and we give it, the utmost priority access to the SSD tier. And then we also have 2 settings that are absolute. Going all the way to off would mean you're pinning it to the spinning disk tier, or going all the way up to 11 would be pinning it to the SSD tier. So none of this is you have a lot of granularity and control, because this is down to the per virtual disk basis on how you want to prioritize access to the SSD tier, which is the most precious tier of storage in a hybrid environment. Now, quite frankly, a lot of customers will just leave everything at the normal setting and let us use our algorithms behind the scenes to move data around as we see fit. But it is nice to know that you have some, tunability from an end user perspective to, prioritize that access, and you don't have to just take our word for it that we're going to do that appropriately. Now, a couple other, basic VM lifecycle management stuff here. If you need to hot add a virtual drive, you can simply do that by clicking Add Drive, type in the new capacity or the capacity you want to give that drive, go ahead and click Create. See a 4th drive pop in here. Same goes for expanding drives. So maybe we want to add, 100 gigs to this particular drive here. Simply type in the new capacity. So we'll go ahead and update that from 300 to 400. We'll see that change right here. So very simple hot add additions from a storage perspective. All right, moving on. We have 17 minutes left, so I'm going to power through this last piece here, and then we'll pause for questions. So last but not least, this is probably my favorite part to talk about from a scale technology perspective, and this is what we have built in from a data protection standpoint. So we come down to the Snapshots tab. Of course, we don't have anything set up. We just created this new machine. But if we wanted to take a manual snapshot, we could simply click this camera button, give it a name. I'll call it Snap because I'm not very creative. Hit Enter. A couple seconds later, we have a data protection plan. Now, the one thing I like to call out about our built-in snapshots, they're radically different than what you generally imagine from a built-in snapshot perspective from a virtualization provider. If we pick on VMware, sorry VMware, but their built-in snaps, maybe if you are currently a VMware admin, you might use them in a fairly limited fashion right before an application update, but you're not going to really utilize VMware snaps as part of your data protection strategy. For our customer base, that's radically different. I'd say 90+% of our customers are utilizing built-in snaps in some form, at least from a local perspective, and many are doing the replication piece of replicating to a stale single node or cluster, which I'll get to here in a second. And the reason for that is because unlike VMware, who does a copy on write style methodology of snapshots that's quite inefficient. I mean, you have to deal with a whole bunch of Delta files as soon as you take more than 2-3 snaps. Any VMware admin that I've ever spoken to is not comfortable taking more than 3 snapshots using VMware snaps, maybe 5 if they're feeling risky. For us, we do an allocate on write style snapshot, which is just using a small amount of metadata and reference counters. We've actually tested taking over 5,000 snapshots per VM with no degradation in performance to the production machine. Again, unlike VMware snaps where more than 3, 4, 5 snaps, you're going to start to degrade and maybe crash the production machine. So completely different. Of course, you're not going to want to click a camera button every time you want a data protection point. That's where automation comes in. So scheduling. Before I click on select a schedule, I'll show you where those are built. Come down here to schedules. We could create a new schedule, but in the interest of time, we'll just look at what I already have created. Go ahead and click edit here. Cool thing here is not only are you selecting your RPO, aka your frequency, but you're selecting the retention for each one of the rules you create. So it'll automatically clean up for it after itself. So here we're taking a snapshot every 15 minutes, keeping those around for 8 hours, doing an hourly snap, keeping those around for 24 hours, a daily at midnight, keeping those around for 7 days, a weekly on Sundays at midnight, and keeping those around locally for 2 weeks and remotely for 4 weeks. So we haven't quite gotten to the replication piece yet, but just keep in mind when you're building these schedules, you have the ability to differentiate retention policies on what's being kept locally versus what's being replicated to the secondary site. So maybe you have a storage heavy secondary site, you want additional retention over there, you could go ahead and do that. Maybe on the flip side, you don't have that much storage over there, so you only want a couple weeklies on the remote site, but you want 4 on the local site. You can do that. You simply click this little check button, set whatever retention policy you want. So if we determine this is a good schedule for this particular workload, simply go ahead, select the schedule from the dropdown, click update, and away you go. So now for the life of this VM, it's going to follow the schedule unless, of course, I change the schedule or remove it. Another cool piece that we've added from a local protection perspective is if we just go ahead and look at one of these other random machines I have here, we've always had the ability to go ahead and create a full clone of the machine from any point in time snapshot. That's obviously useful for if you have a machine become corrupted and you need to, for whatever reason, restore the entire machine, or knock on wood, because I don't even like to bring this up again. I mean, I've said it a few times, but if ransomware ever comes about, obviously coming to a no unhealthy state and being able to clone that machine from that point in time is very important. I've had a few customers, unfortunately, within the last few months that have been hit with ransomware, and they came back to us and talked to us about it. And we've learned a lot that even outside of their backup products that they have on top of us. Unfortunately, none of those customers had implemented Acronis yet, otherwise they might have mitigated those risks completely, but they were using other third-party backup products. But they actually went to our snaps as that restore because our snaps are unchangeable snapshots. So as long as you have a snapshot that was taken pre-infection, that's going to be your easiest and quickest restore point. So again, that's the full restore. But there's use cases where you don't want to necessarily restore the entire virtual machine. In that case, you can go ahead and expand any of your historical snapshots and kind of get a look within that snapshot. So we have a snapshot from November 6th here at almost 1 in the morning. I could go ahead and clone and mount an individual virtual drive from that point in time snapshot back into the same machine or to any other virtual machine on the Scale system. So let's say we wanted to mount it back into that brand new machine that we just built, this 500 gig drive, go ahead and click clone and mount. We can see it's taking an action over here. What's going on? Well, it's going to pop in an additional 500 gig drive here from that point in time snapshot. So what I see a lot of customers do is have basically a little utility virtual machine, a backup machine, file restore machine, whatever you want to call it, sitting on the cluster that they can, it doesn't need to be powered on. It can be powered on, powered off, whatever, that they can go clone and mount virtual drives from historical snapshots of other machines back into that machine to do things like, maybe grabbing an individual file. All right, so a quick summary on the data protection piece as a whole. So obviously the active data itself is redundant. We're wide striping and mirroring the data across the cluster. wide striping so we can take advantage of all the available IO and mirroring for redundancy's sake. That's why we're able to lose any singular component. We can lose multiple hard drives. To us, that's kind of a trivial non-event. If we do lose a drive, what happens is it automatically remirrors the data on that particular drive to the other or to another place, so restoring redundancy from a drive perspective. Also, from a hard drive failure perspective, it's quite a bit different because, historically, when you're talking about SANs, I mean, you carve out RAID sets, and, if you have a RAID 5 and you don't have a hot spare sitting there, that can be a hair on fire moment. And then when you do, swap in the new drive into that RAID 5 set, well, that's IO intensive parity recalculations going on. For us, when that happens, when we have a drive failure, first of all, we'll preemptively fail out a drive if we're seeing it error out. But to get to that point is we swap in a drive, there is no rebuild going on. Essentially, our storage layer just says, cool, now I have this new place to write. We'll, over time, slowly balance that so that it is balanced with the other drives in the system. But there is no automatic rebuilds that are happening that are, kind of nervous moments. So then we have the ability to take manual snapshots. We have the ability to automate those via schedules, like I just showed you, and then we can even get a little bit more granular and restore individual virtual drives from historical snapshots. But that's all from a local perspective. So if the entire cluster gets wiped out from a true, let's say, natural disaster or whatever, that it's actually unrecoverable, it's gone. Well, that's everything we've just talked about. Unfortunately, if the entire cluster is destroyed, doesn't do you any good. So that's where the replication piece comes in. So before I click on setup replication, I'll show you where that's set up. You come to Control Center, down to remote clusters. You can see we have one cluster here and then a single node. So again, a very common architecture is to do a single node for DR. So we'll show you what that looks like. You also get a live view of what's going on with your remote clusters right from the single pane of glass as well. See if there's anything unhealthy. Hey, we have 6 notices here. We could easily just pop into this cluster and figure out what's going on. But for the purpose of this, we'll just go to the single node. The single node looks exactly the same, except for it's 1 block rather than 3 blocks because it's obviously a single node. So if we wanted to replicate over there, we simply click on Setup Replication, pick that as a target, click Replicate. Now, if we hop over here, it should flow under that same tag, and we should see it replicate over. Now, a couple points to note about replication. Of course, the initial replication is going to be a full copy. So what we generally recommend if you're dealing with terabytes and terabytes of data is to ship the DR node or cluster to the same primary location and set those up next to each other so you can obviously do all that initial seeding on the local network, so you're not trying to send terabytes of data across the WAN there. So do that initially and then move that out to your secondary location, because after that we're just using change block tracking. We're going to only send over the changes since the latest successful replica. Also, on top of that, we are compressing and encrypting that across the wire. In the event that you actually need to fail over, well, you'll see that these look a little bit different. We don't have all of the options around the tile. That's because these are essentially repositories of data protection points at this point in time. If you need to fail over, you simply go to your latest and greatest snapshot. I'm assuming it would probably be your latest and greatest. Maybe if it's something like ransomware or something, you'd go to an earlier snapshot. But you'd simply go ahead and clone from that. And within a couple seconds, you have a virtual machine that's ready to be powered on. And that's the extent of the failover process. A couple other things here, just real quickly. Updates are handled really slick from a scale perspective. We don't have an available update, but if we did, there'd be a green button up here that says apply update with all of the release notes listed. And what happens when you kick off an update is it's all non-disruptive. So what I mean by that is it's going to live migrate the virtual machines off of node 1 and bounce them across the remaining nodes of in your cluster. Apply the update to node 1, power cycle, whatever it needs to do to node 1 to fully complete that update, bring node 1 back online, move over to node 2 and do the same thing. Live migrate the machines off of node 2, put them on 1 and 3, apply update, and so on for however many nodes you have in the cluster. So I have sales guys that like to say, hey, you could do this at, noon on a Tuesday. And I mean, I guess technically you could, from a technical perspective, I'd still recommend doing it on what you deem more of a slow time, but virtual machines all do stay up and running during that update process. So the idea of having to, come in on the weekend, bring stuff into maintenance mode to do updates, that, goes away in the scale world. From a user perspective, of course, we have role-based access controls, so you can do a read-only and admin role, or if you want to give a custom role here, you can specify specifically what you want to give a given user's ability to do within the cluster. And then last but not least, this remote support tab here. This is pretty cool. So one of the things I probably didn't do enough justice in talking about during the presentation is our support team. Our support team is all US-based, 24/7, and they make my job a heck of a lot easier because I have a whole lot of customers that are super happy. And they're really two resounding things that I get from a feedback perspective from our existing customer base. One is that their lives got a whole lot easier for managing their virtual infrastructure, so they love that, obviously. But two, if they do have any type of issues with the infrastructure, they get to deal with our scale support team, which I would argue is actually a positive thing because they're good. They're good at their job, and we have a lot of happy customers. But what I'm getting to is, if you do ever have to deal with them, likely you'd be on the phone with them. They'd say, hey, I'm going to provide you a 5-digit code. You'd enter in that 5-digit code under this remote support tab, then click open connection. What that does is that creates a secure SSH tunnel back to our support server, where then our team can do, kind of get a behind the scenes look at what may or may not be going on within your cluster and really get hands on and be able to diagnose that without, just kind of reading off a script. Did you try this? Did you try this? So they like to get their hands dirty. But that is Scale in a nutshell. So I hope that was beneficial. So I'll just pull this up here. And with that, I'm going to kick it back to Jim and Steve to kind of close out here. If there was any questions, feel free to fire them away if anything came in on the chat, Jim. Otherwise, I know you have, I think, a gift card to give out. So
you bet. No, thanks, Jared. We didn't have any questions come through. I did want to throw out there to those that are listening, CEC has a production hyperconverged and HC3 cluster in, and that's what we operate, our servers off of. We also have a redundant node that we replicate to, so that we could, in the event of a disaster, like say straight line winds that are over 100 miles an hour, would come and knock your power and connectivity out. We do have a node that we can bring up all of our production servers. This played a big role if you joined us in the last webinar with Steve and I, the 20 minutes of tech that we had, where we talked about that scenario that popped up where we're in Iowa and Wisconsin. Iowa loses connectivity and power in most of the offices. And Wisconsin just said, geez, guys, it's just a thunderstorm. What's your problem down there, right? So, putting ourselves in that business resilience mode is actually in play, working today at CEC. Also, we have one of the Nook clusters that Jared had referenced, the HE unit in a lab. And the reason I bring this up is if anybody wants to any of our customers want to take a look at this, in play, we have it at CEC. We wouldn't even need to go out and reference another customer. So that's all here. And I guess the last and most important piece is the $100 gift card. And Steve has helped me with that drawing. And we have drawn Jim Sartorius. So we'll be in touch with everybody. And like I said, if you have any questions that arise, please reach out to myself, Steve, Jared. We're all willing to help. Thanks.
Thanks, everyone. Have a good day.